A lime is sliced in half along its great circle, which means there will be two equal halves. A great circle is the largest possible circle that can be drawn around a sphere. All spheres have great circles. If you cut a sphere at one of its great circles, you'd cut it exactly in half. A great circle has the same circumference, or outer boundary, and the same center point as its sphere. All the meridians on Earth are great circles. Meridians, including the prime meridian, are the north-south lines we use to help describe exactly where we are on the Earth. All these lines of longitude meet at the poles, cutting the Earth neatly in half. The equator is another of the Earth's great circles. If you were to cut into the Earth right on its equator, you'd have two equal halves, the northern and southern hemispheres. The equator is the only east-west line that is a great circle. All other parallels, lines of latitude, get smaller as you get near the poles. Great circles can be found on spheres as big as planets and as small as oranges. If you cut an orange exactly in half, the line you cut is the orange's great circle. And until you eat one or both halves, you have two equal hemispheres of the same orange. Great circles are also useful in planning routes. The shortest path between 2 points on the surface of a sphere is always a segment of a great circle. Plotting great circles comes in very handy for airplane pilots trying to fly the shortest distance between 2 points. York to Madrid, if I asked you which line is shorter, you'd say the straight one, right? However, a straight line in a two-dimensional map is not the same as a straight line on a three-dimensional globe. This is why flight paths travel along an arc between an origin and a destination. Now here's how the same flight paths look like on a sphere. Remember that the straight line in the Mercator map above followed the 40-degree latitude line. A great circle generates two arcs, with the shorter one being the shortest path. Here is the shortest path and how the plane is angled to create the shortest path.